Hi Algebra 2 class, this is Unit 2, Lesson 5, and the topic today is one-to-one functions. So we're first going to start by writing the definition of a one-to-one function. A one-to-one function is a function, and just to remind you what that means, to be a function, each x has only one y. So it's a function where each x has only one y. That's just a regular function. But a one-to-one specifically means it's a function in which each y value has one and only one x value. So a regular function just means each x has only one y, but a one-to-one function means that each y has only one and only one x value. So what do we look for? For a regular function, we just want to see that there's no repeating x's. For a one-to-one function, no repeating x or y. Oops. No repeating x or y value. All right. So to determine if a relation is a function, we use the vertical line test. And we were just making sure that the x's didn't repeat. So this is just to see if a relation is a function. Vertical line test. To see if it's a one-to-one function, we use the horizontal line test. So now I need to look left, right to see if any of the y's repeat. So let's look at some that are in a graph, some that are in a table, and we want to see if each of the relations below are one-to-one functions. So I actually don't know it's even a function, it's just a relation. So some of these might not be functions at all. All right, first one, number 1. -2 goes to 1, 0 goes to 2, 5 goes to 6, and 9 goes to 6. Basically, I have 5 going to 6 and I have 9 going to 6. The y repeats. So this is not a one-to-one function because this repeats right in here. Number 2, I have the points -2, 1, and -1, 1. So once again, the y is repeating. So it is not a one-to-one function. For this one right here, I am going to see if it's a function because it passes the vertical line test. Here are my vertical lines. But now let's see if it passes the horizontal line test. I'll pick a different color. Horizontal line. There are 2 points. There are 2 y's. Okay, so my answer is no. This is not a one-to-one function. It fails the horizontal line test. Okay, there's the point 0, 1, and there's the point 4, 1. My y's are repeating. All right, number 4. Let's try and do the horizontal line test and the vertical line test. So yes, it's passing the vertical line test. Here's a vertical line. And then let's go left, right. It passes the horizontal line test. So yes, that is a function and it is a one-to-one function. Same thing on number 5. Yes, it is a one-to-one function. Any vertical line I draw just goes through one point only. Any horizontal line I draw just goes through one point only. Number 6 is no, because it fails the horizontal line test. If I was to draw a horizontal line right here, it has 2 y values. Number 7 is not even a function because it fails the horizontal line test. So it fails the horizontal line test and it also fails the vertical line test. So it is not a function. If it's not a function, it cannot be a one-to-one function. So my answer is no. Number 8, it passes the vertical line test, but it does not pass the horizontal line test. Look, 2y's, so no, it fails the horizontal line test. All right, and number 9, it does pass the vertical line test, but it's failing the horizontal line test because look, there are multiple points right here that have that same y, so no, it fails the horizontal line test. All right, let's look at a multiple choice question with a table. So flip this over. Number 10, of the 4 tables below, one represents a relationship where y is a one-to-one function of x. Determine which it is and explain why the others are not. All right, so if we look at number 1, look at this, my x repeats. So this is not even a function. Not a function, x repeats. Number 2, all right, x's are all different. Let's look at the y's. Oh, these y's are the same. So it's not one-to-one. It's a function, but it's not one-to-one. The y is repeating. Okay, so 1 is no good, 2 is no good. 3, look at my x's, 1, 2, 3, 4. Look at my y's, 2, 4, 8, 16. So yes, this is my answer. There's no repeating x or y. So no repeating x or y. And just to look at number 4, -3, -2. Oh, look, my x is repeating right here. Oh, and my y's are repeating. So 4 was no good. All right, 11. Consider the following 4 graphs which show a relationship between the variables x and y. Circle 2 graphs above that are functions. Explain how you know they are functions. And let's start with that. So which ones are functions? Well, to be a function, when I'm doing a graph, it has to pass the vertical line test. So let's see which ones of these pass the vertical line test. 1 passes the vertical line test, so 1 is good. 2 does not pass the vertical line test, so 2 is not good. Number 3 does not pass the vertical line test, so 3 is not good. And 4 passes the vertical line test, so number 1 and number 4. Pick a different color. Of the 2 graphs you circled, which is one-to-one? Explain how you can tell from the graph. Well, to be one-to-one, it has to pass the horizontal line test. So now I'm going to, out of choice 1 and choice 4, these are the ones that I'm looking at. I'm going to look at 1 and 4. Which of these passes the horizontal line test? 1 does not. Look, there are 2 points there. 4 does. It's only intersecting in 1 point, any horizontal line. So 4, number 4, is one-to-one. It passes the vertical line test and the horizontal line test. Okay? And number 12. Which of the following represents the graph of a one-to-one function? Again, to be one-to-one, it has to pass the vertical line test and the horizontal line test. All right, looking at number 1, fails a vertical line test. Number 2, fails a horizontal line test. Number 3, vertical line test passes. Horizontal line test passes. So number 3 is my answer. 4 fails a horizontal line test. Okay, these are quick. I know there's a lot of them. Let's look at the last page here. All right, number 13. I want to know if it's a function. To look at the y's. All right, I'm sorry, the x's. So to see if it's a function, I want to look at the x's. Are all my x's different? If all my x's are different, then I'm good. So every single x is different. -1, 0, 1, and 2. So is it a function? Yes. X does not repeat. Then to see if it's one-to-one, I want to look at the y's. Oh, every single y is 1. So is it one-to-one? No, because the y repeats. Same thing for B. which function is not one-to-one. So I want to know which is not one-to-one. So basically, I'm going to look at my, let me get the highlighter out. I'm going to look at my y's right there. So I want to make sure that the y's are not repeating. Not one-to-one. So look at my y's. All different. And my x's are all different. So therefore, this is one-to-one. That one's good. Number 2, 0, 1, 2, 3. Good. Number 3, 1, 0, 3, 2. All my y's are different. That's good. Number 4, 1, 0, 0, 2. Oh, see, they have the same y's right here. So this one is not one-to-one. All right, they're asking me which is not one-to-one. All right, last thing, algebra functions. We can perform arithmetic operations with functions. In general, if f of x and g of x are functions, then f plus g of x equals f of x plus g of x. All right, so I can sort of separate them. So when you're adding the two things, I can separate them. If you're subtracting them, then I'm just going to subtract them. See how I'm subtracting them right here. When I was adding them, I add them. When I'm subtracting them, I subtract them. This is multiplication when I have the letters next to each other. So look what I'm doing. I'm just multiplying. This is division right here, f divided by g. So this is f of x divided by g of x. So sort of separate them. How does that work with an actual problem? If f of x equals 2x squared and g of x equals 5x, find f plus g of x. Well, f plus g of x equals f of x plus g of x. So I'm just going to take them and I'm going to add them. F of x is 2x squared. G of x is 5x. I can't combine those because they have different exponents. They are not like terms. That's it. That's my answer. F minus g of x, well, equals f of x minus g of x. So I'm going to take f of x, which is 2x squared, and I'm going to take g of x, which is 5x, and I'm going to subtract them. And that's my answer. C, I am multiplying. So f times g of x equals f of x times g of x. I'm going to take f of x, which is 2x squared, and I'm going to multiply it by g of x, which is 5x. Now these are multiplying, so I don't need them to be like terms. I'm just going to multiply those coefficients together, and then I'm going to add the exponents. F divided by g of x equals f of x divided by g of x. F of x is 2x squared. G of x is 5x. Now when I'm dividing, I subtract the exponents. 2/5 can just stay 2/5, but then I subtract the exponents, so it's 2/5 x. And E, I have a number in front, so 3 times f of x, 3 times f of x happens to be 2x squared. 3 times 2x squared is 6x squared. And g minus 3 of f of x equals g of x minus 3 times f of x. Well, g of x is 5x. F of x is 2x squared, but I am multiplying that by 3. So it's 5x minus 6x squared. And that would be my answer because those are not like terms, so I cannot do anything to them. Okay, so then we're going to try the practice problems in class tomorrow, and that is lesson 5.